So for same range, because here it is given that the projectiles are having same range for two angle of projection, therefore we can say that the angles will be, both angles will be complementary to each other. So if the angles are complementary to each other, what does that mean? It means that if one angle is alpha, let one angle, okay, so if angle A, let us call this angle 1, this angle is alpha, then another angle, okay, let us call this angle beta, it is equals to 90 minus alpha. This will be the case. Now we know that, so we know that t, that is time, t1 is equal to 2u sine alpha by g. This is the formula for the time, okay, where u is the velocity and the sine alpha is the angle and g is the gravitational acceleration. And similarly the t2, because there are two angle of projection, so for the another angle of projection the time will be t2, that is equals to 2u sine beta by g. But as you know that beta is equals to 90 minus alpha, so we can say that 2u sine 90 minus alpha divided by g. And sine 90 minus alpha is equals to cos alpha, therefore it becomes 2u cos alpha divided by g. Now if we find the relation between t1 and t2, so we can say that when t1 and is multiplied by t2, so t1 multiplied by t2 is equals to 4 u square, as you can see over here, sine alpha, 4u square sine alpha multiplied by cos alpha divided by d square, and this is equals to 2 r by g. And how does this r comes over here? R is known as range. So this r is known as range. This is our range over here. Therefore r is equals to u square sine 2 theta by g. Now when you will put this sine 2 theta by g, it will become, this is how we subtracted the value of r over here. So I am telling you this. So u square sine 2 theta by g, that means it is equals to u square sine 2 theta, that means 2u sine theta cos theta divided by g. So the relation between t1 and t2, so t1 multiplied by t2, it becomes 2r by g, and this is the value of t1 multiplied by t2. Hence our relation between the time t1 and t2 is equals to 2 multiplied by range, that is 2r divided by g.